Okay, so for this video, we're on page 6 of our notes on Unit 2. The so this part, the first prompt that's on page 6 is trying to explain to you what bearing means. So the first sentence says the following bearing will be measured in degree clockwise from the north. Now, let's go ahead and explain what I mean by that. Let me explain. Do you guys remember doing the regular vectors? So this is my regular one. Okay, and the one in red that I'm going to draw would be our bearing one. So let's go ahead and see what that means. This is our bearing, and the one in blue will be our normal. On it, remember how our 0 degree was right here, and then we went counterclockwise. So this was our 90 counterclockwise, and then 90, 180, 270, and 360 back again. We can just go around and around and around counterclockwise, correct? So this is our normal / our math way. However, in real life, we have a quadrant bearing, well, the regular bearings. On our regular bearing, this is what this first sentence is telling you. Our 0 is at north. Not only our 0 is at north, it's going to go the other way. It's going to go clockwise. So this will be our 90 degrees. That would be 180. And this right here will be 270 degrees. And that will be our 360 degrees. And knowing that, let's go ahead and try number 1 together on page 6. We're still on page 6. You may need a separate piece of paper for this one. So let's try to draw what this looks like here. So I'm going to go ahead and draw our little thing. So 11 miles north. The north, south, east, west stays the same whether or not you're in bearing or the normal math mode. Okay. So it says 11 degrees north, well, 11 miles north, which is 0 degrees. So let's go ahead and get there. I'm going to draw my vectors with this. So here we are. So from 0 to there. That black line, I'm going to make that thicker so we can see. From here to there is my first thing that I drew. And I'm going to label that as my vector A, just because I can. Okay, and that was 11 miles long. Followed by 6 miles along the bearing of 70. So that's going to be my B. Vector B. But before, vector B. Before I do, I'm going to go ahead and get my vector A first, like we did in class the other day. Since it's going up north 11, that point right there would be 0, 11. Now we're going to go on to drawing the vector B. So let's do that. I'm going to do it in blue. So my vector B will be right here. Okay. So my vector B here on my quadrant, so I'm going to draw my quadrant bearing right here. It needs to be 70 degrees, bearing up 70 degrees. So here's my 0 degrees, here's my 90 degrees. I'm going to go clockwise. So my vector for this one will be about here. That's as good as this is going to get. So that's about bearing of 70 degrees. So from here to here is 70 degrees is what we're saying. And that is 6 miles long. Now, in order for us to do this, we're going to go ahead and have to do our regular thing here. We're going to drop our perpendicular line. Now, here's the thing. Your calculator does not have a bearing mode. You're going to have to just do your regular. So we're going to have to do our regular method here. So this right here is 20 degrees since the whole square right there is 90 degrees. And we're going to go ahead and find our x distance for it. Okay, and our y distance for it, because that's what we're looking for. X distance for it and our y distance for it. So we're going to have to do our right triangle trig with this one. But remember, you can either set it up, or our shortcut was magnitude times cosine of the degree. And I'm going to erase this so we can have some room right here. Or magnitude of the sine of the degree, because cosine and sine represents x and y. Alright, now let's go and get our calculators out. We need 6 cosine of 70, so 6 cosine of 70. Make sure your calculator is in degree mode. And that's 2.052, so that's 2.052. And our 6 sine of 70 is 5.638. 638. So that is our vector B. Not too bad. Okay, so this is, even though it's in bearing mode, your quadrant point does not change. That makes sense, because our quadrant is still the same quadrant. Now let's do our resultant vector. Remember how our resultant vector is, I'm going to call it R if that's okay, it's obtained by adding the first 2 vectors. So we're going to go to add them together. So 0 plus 2.052 is 2.052. And if I add the y's together, it'll be 16.638. So once I obtained my vector, I'm going to go ahead and draw it for us so we can kind of see what all we got here. So on my coordinate plane, my vector R, my resultant vector, is now going to be at 2.052 and 16.638. So I'm going to be over 2.052 and up 16.638. So let's go ahead and draw that. And it's going to look somewhat like it's starting at 0, and that's going to be my resultant vector. If we add those 2, that's where we say we're going to end up at. Now let's go ahead and, so from here to here, once again, is 2.052. And if I drop the perpendicular line, my y distance is 16.638. Now let's use our, let's go ahead and find our magnitude first. Remember how we notated with the absolute value bar? So our magnitude is going to be square root of, when you do Pythagorean theorem, it'll be 2.052 squared plus 16.638 squared, all under square root. So let's see what we would get for that. The square root of 2.052 squared plus 16.638 squared. I think I typed it in right. That gives me 16.764. 16.764. So we're saying that vector has a distance or magnitude of 16.764. Now we need to go and find our angle, but the angle that this is going to find us is going to be that interior angle or our reference angle. Likewise, we're going to do our angle, like we always do, tangent inverse of y over x, because tangent is y over x. 16.638 over 2.052. Let's see what that gives us. So tangent inverse of 16.638 over 2.052. Alright, that gives us 82.969 degrees. So 82.969 degrees. So that interior angle right there would be 82.969 degrees. However, please recall that we're in a bearing mode, which means this is our 0 degrees, and our angles are counted from 0 to counterclockwise, which means to the right. So we actually, your calculator gives you the regular degree, but you need the counter degree or bearing degree. So in order for us to get that degree from here to here, we'll have to do 90, which is the whole square, minus 82.969. So 90 minus that will give us 7.031 degrees. 7.031 1 degrees. And remember the notation that we had, even though the theta is there, our true theta for subscript r, my angle for our resultant vector, that's how I'm going to notate it, and that's how I know that your true answer is going to be 7.031. So we found our magnitude and our direction of this one.